We present Guess the Unseen, dynamic 3D scene reconstruction from partial 2D glimpses. When capturing videos of people in daily life, individuals are often occluded, suffer from a lack of observations, and are cropped by camera frames. Using this casual video as input, GT reconstructs 3D human appearances. To reconstruct the 3D appearance of humans, we decouple the scene into background and human modules. Both are represented by 3D Gaussians, which can be easily composited and rasterized jointly by concatenating these Gaussians. Each 3D Gaussian of the human model is defined in the shape of a canonical pose, and can be deformed using linear blend skinning into any arbitrary pose. We first render the Gaussians in an observed pose, and calculate the reconstruction loss by comparing the rasterized output to the input video frame. However, due to lack of observations, this alone is insufficient to reconstruct humans. To complete the appearance, we render humans with unobserved cameras and calculate the SDS loss to regularize the rendered appearance of humans in unseen views. We optimize the background and human Gaussians jointly by minimizing these losses. To calculate the SDS loss, we first render each person with a randomly sampled camera. Then we perturb the rendered output with a random amount of noise and query it into a pre-trained image diffusion model. We use OpenPose ControlNet with the projected body joints to reduce possible discrepancies in body pose between the diffusion model's denoised output and the rendered output. Finally, by querying a simple text prompt as a condition, the diffusion model generates a denoised version of the queried perturbed images, which presents a plausible human appearance aligned to the body pose. The SDS loss regularizes the rendered output to be close to these denoised outputs, ensuring that the rendered output from any random view is always realistic and aligned with the body pose. However, the learned distribution of the diffusion model is too wide and varied, causing the SDS loss to converge to a random appearance. To further confine the plausible data distribution of the diffusion model for consistent reconstruction, we use textual inversion. For each person, we collect masked partial observations from the input video. With the collected masked images, we fine-tune the diffusion model and text token using custom diffusion. We utilize ControlNet during custom diffusion to avoid the text token learning pose information. With these customized person-specific diffusion models and text tokens, we achieve much better SDS guidance, which is more consistent with the observed human appearance. To simulate a situation with insufficient observation, we use a panoptic dataset capturing multiple humans at once. All models are trained with a single video from a manually chosen camera. You can see that human nerf fails due to severe occlusion, while our method is free from such occlusion. Shuai et al. Model people and scenes jointly like us, but the parts never observed remain gray, whereas our method completes them with a plausible form. These are the rendered outputs from another view. We also tested our model with the Hi4D dataset, which includes close interactions between people. Our method successfully completes fully unseen parts with an appearance consistent with the observations. Thanks to the fast rasterization speed of 3D Gaussian splatting, our method can render novel views at 300 FPS while showing comparable quality to existing NeRF-based approaches. We additionally studied the importance of each SDS loss and textual inversion with a video cropped at the lower body and trimmed to only the first 10% of frames. Without SDS loss, it suffers from artifacts like hedgehog on both seen and unseen parts. With vanilla SDS loss, it forms the shape of a person and reduces artifacts, but the appearance is not consistent with observations. When we add textual inversion to the SDS loss, we get a more plausible lower body consistent with the input. Adding OpenPose ControlNet to the SDS loss reduces blurry artifacts on unseen parts. These are additional in-the-wild video outputs. The reconstructed avatars can deform into arbitrary poses and be rendered jointly, as shown here, with fast rendering speed. Thank you.